Welcome back to the RE7 Engineering channel. In today's lesson, we are going to explore one of the most essential safety systems in modern buildings, the firefighting system for hotels. Whether you are a student, a mechanical engineering beginner, or someone starting in MEP design, this episode will give you a clear understanding of how to approach a firefighting project professionally, just like real engineers do in the industry. Let's begin. Before we design anything, we must understand the purpose of a hotel firefighting system. Hotels are high occupancy buildings. Guests are sleeping, resting, or staying temporarily. Most of them are unfamiliar with the building layout. In case of fire, evacuation can be slow, confused, or delayed. Because of this, the firefighting system in a hotel must be automatic, reliable, fast in response, designed according to international standards. We follow standards such as NFPA 13 for sprinklers, NFPA 14 for standpipes, NFPA 20 for fire pumps, and NFPA 22 for water tanks. Local fire authority codes must also be respected. So the purpose is not only to fight the fire, but to protect people, reduce damage, and give fire brigades enough time to respond. A complete hotel firefighting system includes several components, each playing a critical role. 1. Automatic sprinkler system. 2. Hydrant and standpipe system. 3. Fire pump set. 4. Fire water storage tank. 5. Fire hose reel system. 6. Fire brigade inlet. 7. Control valves, flow switches, and alarm components. All these systems work together to control or extinguish a fire at its earliest stage. In this lesson, we'll focus mainly on the design inputs and outputs the engineering foundation needed before modeling, drafting, or calculation, what you need before designing. Every engineering project begins with gathering information. We call these input parameters. Let's go through them professionally and clearly. 1. Architectural inputs. You must collect number of floors, number of basements, floor area per floor, total built-up area, building height RDF, ceiling height, layouts of guest rooms, corridors, kitchens, and storage, shaft size and location, false ceiling height. These give you the physical constraints and guide the pipe routing strategy. 2. Hazard classification. Based on NFPA, guest rooms, light hazard acid, corridors light hazard, kitchens ordinary hazard group 1, storage rooms OH1 or OH2, parking basement parking hazard category. Hazard classification defines sprinkler spacing, water discharge density, and design area. 3. Fire protection system requirements. Every hotel requires sprinkler system, standpipe system class 3, hydrant system, hose reels, fire pump set, jockey pump, fire water tank, fire brigade inlet, special systems for sensitive rooms like server rooms. These systems depend on local code requirements, so always check fire authority guidelines. 4. Water supply conditions. You must know, is municipal water available? Does it provide enough pressure? Is a dedicated fire tank required? Where will the tank be located, underground or on roof? Large hotels always require a dedicated fire water tank. 5. Sprinkler design data. Standard values include K factor, usually K80, sprinkler spacing, around 3.6 meters times 3.6 meters, design density, 2 to 2.25 millimeters per minute for light hazard. Maximum coverage per sprinkler, 1821 square meters. Design area, 140 square meters for light hazard. These parameters are essential for hydraulic calculations. 6. Hydrant and standpipe data. Typical values. Hydrant flow, 946 liters per minute. Landing valve pressure, minimum 4.5 bars at top floor, standpipe class 3, riser diameter 150 millimeters, hydrant ring main 150 millimeters. These ensure firemen have the pressure and flow they need. 7. Pump room requirements. We must determine main pump size game, diesel pump requirement, jockey pump size, suction and delivery header sizes. Typical hotel pump size is around 750 GPM at 8.5 to 10 bars. 8. Hydraulic calculation inputs. Pipe material, Hazen-Williams coefficient, elevation difference, friction loss allowance, sprinkler design flow down, hydrant design flow, combined demand. These inputs are used to calculate the required pump, head, and tank size. Introducing the Python calculation tool. On this channel, we believe learning engineering should be practical and hands-on. So I have created a Python calculation tool that helps students compute the essential outputs of a firefighting system. This script allows you to enter your input parameters manually, automatically compute sprinkler flow, compute hydrant flow, compute total system demand, estimate water tank size, recommend pump sizing, suggest pipe diameters. Now we will prepare the appropriate prompt to instruct AI to generate the Python code that will serve as our calculation tool for this project. Before we ask the AI to write any code, we must clearly understand two things: the input parameters required for the design and the output parameters we want the tool to produce. Once these are defined, we can craft an accurate and structured prompt that guides the AI to generate the correct Python script. You may either request the AI to create the prompt first, or you can ask the AI directly to generate the Python code based on the input and output requirements. This ensures that the resulting calculation tool is precise, reliable, and aligned with real engineering practices. Using Python in firefighting design has major benefits. Eliminates manual mistakes, speeds up conceptual design, helps compare multiple design scenarios, trains students to think like real engineers, provides repeatable and reliable results. In the engineering industry, automation is becoming essential. Learning these tools early gives you a massive advantage. Today, you learned why hotel firefighting systems are critical, the international NFPA standards used in real projects, all the required input parameters for a proper design, how to calculate basic fire flows, how to estimate pump and tank sizes, how to use a Python tool to automate the calculation process. This knowledge is fundamental for anyone entering the field of mechanical engineering or MEP design. If you found this lesson helpful, make sure to subscribe to the RE7 Engineering channel for more practical engineering tutorials, calculations, and real-world project guidance. Thank you for watching, and I'll see you in the next lesson.